Great. Hello to all. Thank you for joining me today, despite doing this online. My name is Firuza Nahmadova, and I will be presenting you about my company, DataStakes. The company that I work for, DataStakes, solution for decentralized knowledge for the global south. Before going any further, let me tell you a bit about the company itself. So I'm working as the lead data architect, and as of right now, the data stake is actually working on building data management applications for users uh, who are mostly in the international aid and slash development industries. And our current clients are actually um, minerals and mining trade in DRC Congo. And our application's main focus is essentially enabling the users to safely compile and structure their data so that it is one accessible to many users across the organization, so that it is not in data silos. The second part is that we focus on standardization and granularization, so that again the data that they are creating is made in a created in a standardized way and has more value. The third point is that of sharing. Our applications are made so that they can incentivize and facilitate sharing across multiple users, sharing of data, but without forgetting the side of sovereignty, as in we want to help the sharing users to keep their data safe and keep control over their data. So, what is really the problem that we're solving, and why I'm talking about decentralized knowledge? The more general issue is that of open data. Yes, open data frameworks, initiatives, and open data thinking has achieved many things, making data accessible. But the data that we are creating is still difficult to reuse, even if it's accessible. It's also not often updated depending on the source. And again, depending on the source, it is not always trusted, specifically because there might not be even due diligence that you can do on this data. So, because all open data is not created the same, we really need now to focus not only on the accessibility side, but on the reusability, so that when you are even creating the data, it is created in such a way that it can be used for multiple purposes beyond its initial use. So the point is optimizing reusability of the data. So what does this really mean, specifically for the global south? The general problem is that data collection is always expensive, but now when it comes to the global south, when international organizations need to collect any type of data from the global south, because the data is not reachable or less accessible, the way to go is they will send experts who will travel to these countries, collect the data, and then report it back. And then there's two sides to the problem. The first one is that the initial collection is already expensive. But then the second part is that if you want to update this data every year, for example, and keep it relevant, the only way of doing it is once more to send the expert back for another round of data collection and report it back. And then the real problem behind this, beyond the data collection being expensive, is that there is no data integrity. Because on the organization side, yes, you receive this data, but you have no way of doing due diligence. You don't know really where it came from. And the second part is because you cannot make due diligence. You don't know how the expert decided which opinion is worthy of being reported back, which sources are trustworthy or not. And on the original sources side, the local data producers, there is no way to own the data that you have provided to these experts. There is no sovereignty, and also, despite having collaborated in a way for global decision making, you're not actually involved in it. Instead, the data is kind of taken away from you, and you don't know what's happening to it. And the final problem that is related to the global south specifically is the general idea of the data divide. There is already issues with data availability, the data accessibility, but even when this data is somehow accessed through intermediaries, so the experts, for example, collecting, uh, there is no reward whatsoever for this data that they have produced and shared, collaborated for global decision making. The solution that I've been working on was DataStake. So this will be the DataStake platform, and this is not ready yet, but yeah, the four main focuses is obviously the standardization and the granularization part. So we do have a common data schema that users will have to abide to and map their original data to. Then we have the contextualization, which we do through semantic complexity through knowledge graphs. And then the final and the whole objective is that because the data is standardized and granularized and easily discoverable, there's more higher propensity of these users to collaborate with each other by sharing data. And the whole point of this platform is really that the data that is created in the global south can reach bigger audiences across the world so that it does not stay in a data silo. It is discoverable by many. And once it's shared, it is shared in such a way that they do not lose control over the data. This is why, and I will go through this a bit later in my presentation, this is why we have um, as much flexibility as possible in the sharing settings, which are modular and flexible, and give the opportunity to have a data chain of custody once a data is shared, reshared throughout multiple organizations. And why knowledge graphs? I think this is quite, I'm sure I don't need to explain this to this audience, but because this data is going to be interconnected across users, across organizations, it just makes sense to have it in such a structure. And the way that the users who are connecting their data sets or databases to our platform, they do this through small steps, which is the first one is essentially mapping their existing data to our knowledge graph schema, by which essentially they standardize and granularize their data. Then they do have the option of either having their data or their metadata stored on our side. So they do have the option of not fully trusting us as well. And then once these two steps are done, that is when the data is actually ready for exchange because now it's tradable across systems. Let me now go into the main focus here, the ontology that we have for our graph. And it does cover multiple parts, which I hope you can see on the screen. There's the user management side, there is the transaction management in terms of sharing, and of course, we also have the data nodes. So the way that it works is in terms of user management, you have two primary labels for the user type node, which is the user organization, which acts as the main user, and then you have user persons, which are part of this user organization. Then multiple user organizations can connect to a channel labeled node through a connect relationship type. This is where the actual sharing will happen. Then, in terms of actual data nodes, we have separated into four recognized entities, which is the not in four recognized types of nodes, which is the entity, the location, event, and documents. So, for instance, you might have an entity which is connected to a location through a located in type relationship, in the same way as you could have an event that is also located in a location. Entities could be linked to each other, events could be linked to each other, etc., etc. And we do have also the one more way of having really the chain of custody side of things, where we have a node of labeled origin, and this origin is then connected to data nodes through an origin of relationship. And then we do have one more node, which is really at the center of our data linking strategy, and that is the parent node that you see in the middle, the beige colored one. And that's how we do our linking strategy to connect multiple sources of information about the same common subject. So just previous to me, there was a presentation actually about inconsistencies, and in our case, we actually don't not stop inconsistencies in a way. So, for instance, two user organizations could have connected two different entities, and these two entities so happen to have been recognized as being about the same subject. In which case, we would connect them to a common parent entity node with a parent of relationship. So this actually adds extra hierarchical structure to our graph by making a common subject of information. Let me just present a small example of this because that will be slightly easier. If you focus on the left side here, for example, you have one user that has connected some data, and it happens to have an entity named Penaltech, which itself is associated with a document named financial data. It also has another document named logo, and they are linked to the entity. It also says that the entity Cornell Tech is linked to the event KGC 2023, and both of these entities and events are located in the US. Now, on the other side, we have another user, user two, who has also connected their own dataset. They happen to have an entity called Cornell Tech University and an event called Knowledge Graph Conference 2023, both of which are located in the US. Now, this could you can already see where I'm going. This could be done either by a person or by through a suggestion model. We can make a connection between the two entities, Cornell Tech and Cornell Tech University, because we know that despite them being written somewhat differently, and they might also have some other properties that are not exactly the same, there might be inconsistency. They actually talk still about the same subject of information. And this is where we would create a parent entity named Cornell Tech that acts as the parent of both of these entities. And in the same way, to the bottom of the screen, the two KGC 2023 and Knowledge Graph Conference nodes could be connected through a parent node that links them all together. So the whole point of this parent node is really connecting multiple sources of information across data sets, across organizations, so that we can also use this for example, in a suggestion model to elevate our discoverability features. What happens once that you have discovered data? That's where the sharing contracts really come in. And as I said, they're made to be flexible. You can put them at a user level, as in apply to all your data, or it could be at the data set level. They could be at a specific data node level, or even property level in the future. And the four preferences that you can choose is one, the discoverability. So, which type of user can discover my data? You could say, for example, only non commercial users can discover. You could also choose the accessibility. So, can this be accessed immediately upon request, or is this through an agreement? Is this through payment? Availability is going to be, is this a temporary access, or is this a permanent access? If it's temporary, for how long? And then the licensing, which is probably the most important one. What happens to your data once you have shared it? Can they reshare it? Can they make derivatives out of it, etc., etc.? So this is how we want to warrant the control over the data and the safety, in a sense, of sharing. Um, yeah, I'll try to. I only have 4 minutes, but okay. The other thing that I really wanted to focus on is that I did show you our graph and the schema that we have, the ontology. But as you might have noticed, it's actually quite minimal. And was actually done on purpose, as in we wanted to start off from a minimal viable graph, as we have called it, a data stake, where we recognize really the basics of the type of data that will be stored on the platform or connected to the platform, because we want to do almost to crowdsource the data, because we don't want to create yet another siloed ontology, siloed dictionary of or taxonomy. We want to move on and evolve our schema based on the data that is connected to us, which means that there will actually be multiple granularization processes from one version of the schema to another. We do, however, have one type of a general direction that we expect for the schema. So, for example, we do expect to create categorical type nodes. We do want to recognize specific properties. So, for instance, In this on this slide, you can see the entity data stake has a number of personnel, number of equipment. So this is kind of where we want to go, but we decided not to restrict ourselves essentially with a very specific schema from the beginning. And you might ask yourselves who is going to remap their schema each time once they are connected. We do expect that at some point there will be a certain threshold that we will have reached, because obviously the first processes might be heavier in terms of rework, but in time it will be more streamlined, and the newer versions will have less changes in between the newer and the previous one. And that's how we see the scalability of it, and as well as the fact that it will not be only based on the mappings of our clients. It will also be done by our teams, who will map, for example, open source data sets to connect them to the platform, and thus make also changes to the schema when we realize that there's maybe a property that is common over multiple data sets that makes sense to integrate into our schema more officially. And yeah, I'll just try to finish it off before the questions. What is really the impact that we are trying to achieve? Just as a review, the first part is obviously that the local data producers and holders, they can make their data interoperable, discoverable by many throughout the globe, and then also shareable through data contracts. In the second time, that means that global organizations, they actually have access to relevant local data through sharing contracts, and they can triangulate from multiple sources and at a fraction of the cost, instead of sending, for example, an expert. And also, because they are triangulating and because they have access to a chain of custody, they can actually do due diligence on the data that they have acquired. In a third time, it means that the local data producers have control over their data. They can actually control how it's used. They can take credit for their collaboration, also gaining reputation if they have collaborated with a certain organization, for instance, and also be more involved really in the global decision making. And the fourth point is that because these organizations are now using multifaceted data, they now can do due diligence on the data that they have acquired and used, for example, for a decision. They can thus make more efficient and credible decisions, where they can say, we made this decision because this is the data that we have received from these sources. And yeah, that's what we are doing, and I hope there are some questions. If there is anyone who would like to discuss or even suggest anything for our project, I'd love to talk.
There might see
Cool. Thank you for that. Do you, where are you in terms of your platform's maturity? Like, do you have some examples of some data that you have, or some organizations that, or areas it's being collected from?
So as of right now, the platform is in very early stages of development, as in we have the schema and we are planning the development itself. But when it comes to the general ideas that I have mentioned, we do have this at a smaller scale within the applications that we are currently already maintaining. Uh, Both of these are in the mineral and mining industries in the DRC. And so one of the examples that I can bring in terms of how important the sharing is, for example, both of these projects are focused on mining transparency. So obviously they're going to really focus on acquiring, collecting and compiling data on on these two subjects. But then, for example, in terms of events, they might have incidents that are related to health and safety, or maybe human rights, or children working at the mine, things like that. And obviously, this data, if it's not being shared and that no one else knows that it exists, it's essentially just destroyed, and no one is going to use it ever, because specifically it's not discoverable, it's not connected to anything bigger in terms of ecosystem. um, and that's really the problem that we want to solve, so that data, once it's created, it's discovered by others, it can be reused, and whoever connected it can actually get rewarded for it.
Thank you.
You can actually get a demo on our website. If you check out datastake.io, you can test out one of our current applications.
How are you engaging the local communities that are impacted by this in the development of your schema, and what the other criteria are?
So how are we developing our schema based on the local data holders? Is that your question?
Just say yes.
Or
Yes.
yes. As of right now, we have not started looking into actual granularization processes because we haven't even developed the minimal viable graph, as I called it earlier. But in terms of specifically the mineral and mining trade industries, because we already have applications within these specific industries, we do take into account the suggestions that we receive through our bugs and fixes messaging process. So those things are kind of kept in mind for any future granularizations once the platform is actually existing and offered as a service.
Hello, thanks. Thanks for your presentation. I may have missed the first couple minutes. I was kind of curious under the hood. When you have a very minimal schema, which I see. Is this an owl-based ontology? Is it a property graph? What are you using under the hood?
Yeah, it's a property graph, and the way that we want to do it is that it will be a mix actually of Neo4j and MongoDB, as in the Neo4j will essentially act almost as an index for really the storage, the real storage that will be on Mongo, and yeah, essentially having almost all of the metadata on Neo4j. The thing is, we don't really know how scalable it's going to be once we have more data on it, and not only in terms of performance, but also in terms of pricing. But as a beginning, we have decided to go for this in between, and potentially in the future having everything on a graph database.
Anyone else? Okay, I think that's about it. I think we're out of questions. We're just about out of time. We're on time. Thank you.